Hello and welcome to the next segment of Introduction to Autonomous Systems. If you recall, in the last session we had brought in two important ideas that make the agent intelligent and rational. These were bringing in the idea of utility and learning, and we said that once we bring in the idea of learning, any of the other agent designs can be made intelligent just by bringing in the concept of feedback and self adaptation. Now, this also brings us to an earlier discussion on the 5 attributes of autonomy that we had seen in the beginning of our discussion on this course, and 5 attributes were perception, reflection, planning, goal management and self adaptation. With learning, we now bring in the self adaptation also, that kind of rounds off all the 5 attributes and that actually brings agent very close to what it would be as an autonomous system. Now, we also had mentioned, if you remember at that time, the 6th attribute, which was sitting outside of the 5 attributes and was being coordinated by this particular attribute, what we gave the name as knowledge base. And we said that the knowledge base is the ultimate repository of all what the agent knows or captures during either the design or during the operational phase, or what we call the design time knowledge and the run time knowledge. Now, we immediately realize that in order for us to complete our understanding of an intelligent rational agent, its design has to include this particular aspect of knowledge as an important element of the design of these agents, and it is also an essential attribute of any autonomous or an AI system. So, you can look at any autonomous or an AI system, its main driver from the background would be the knowledge that either it has been given at the time of design or it has gathered through its experiences while operating in a real world scenario. In fact, there are many schools of thought in which they say that we are going to design agents based only on the concept of knowledge itself. And here let me recall a term that I had used in the very beginning when we were talking about agentic AI designs. So, I said that strictly speaking, the best agent in this world could be the agent which knows everything, or omniscient agent, which means it has an action for every possible percept that might occur in a given environment. Of course, we know that it is only a kind of an ideal and we may want to achieve it, but our knowledge is never going to be complete. But the philosophy that we can now design an agent based on the knowledge starts making sense, that it is possible for us to use knowledge as driver for the design of the agent. So, let us see how we can actually go about doing this, and this immediately brings us back to understanding the concept of knowledge itself. Now, knowledge is something which perhaps is not something which we can give a physical form. As a concept, the only thing which we can say about the knowledge is that it is intrinsic or intuitive. As we humans always claim that we know things that help us to do things. For example, how often we have made such statement, I know there is an ice cream shop at the next corner. Now, that knowledge must have come sometime previously when that person would have been passing through the area and would have noticed a signboard, and that information which was processed through the learning mechanism and got stored. So, next time the person says, I know it is there, and that is what also helps us to do many different things. Now, some people or detractors have claimed that how do you know? But we need to understand that these statements are not really empty as we might think, because they actually make a strong claim about how intelligence of humans is achieved. See, this is the point which we have not yet fully understood, that how humans achieve intelligence. Right from the inception when we are born, and then we kind of grow into an environment, in a home, in school, in playground, in different settings. So, there is some amount of reflex which is there, but we also at some point start generating knowledge through a process of reasoning, and that is something which is so intrinsic and intuitive to all humans that we are doing it almost all the time, but in a subconscious manner. So, reasoning is a trait that actually is operating on the internal representation of the knowledge, and essentially is the basis for designing knowledge based intelligent agents, which means that if I have collected knowledge from various sources, lot of knowledge I have collected, and then I start doing the connection between the various components of that knowledge in a logical manner or in a kind of a reasoned framework, then I am in a position to take actions which are likely to be intelligent as well as rational, and that becomes the basis for designing knowledge based intelligent agents. Now, we start getting slightly deeper into the implication of this knowledge or the knowledge base itself. See, we have been using this phrase knowledge base right from the beginning at different times, but we have not really defined it in a very crisp manner. We have just kind of used it as a kind of a placeholder, which from what we understand is something which will give us whatever we want, which means we are treating knowledge base as something which is a repository from where whatever information that we need to take an action we can extract. But now we reach a stage where we need to be a little bit more definitive in terms of our interpretation of the knowledge base itself. So, generally it is considered to be a collection of sentences, and I have put that word in quotes, which means they are not typically the sentences that we are used to. We keep speaking sentences, we keep reading sentences, we keep seeing sentences. So, we in some sense know what sentences are, and right from the school days when we are taught grammar, how to construct sentences, how a meaningful sentence is constructed, all those things we kind of are used to, but we are now coming to a place or a point where we need to make it lot more crisp and definitive from the point of view of designing a knowledge based AI agent, which is intelligent and rational. So, these are essentially considered as technical entities that need crisp definition, and of course, they are somewhat similar to sentences found in natural languages, which we are already familiar with, but then there are important differences as well, as we shall see as we go along. So, in this context we note that a sentence is expressed using knowledge representation language and generally contains some assertion about the world, whatever it could be. I mean, depending upon the context of the agent and the kind of task or the action it is expected to take, there will be some assertion about the world or the environment around it. We also note that we can form complex sentences from simpler sentences, just as we do in other languages, and that sentences which are standalone, what we call the given knowledge, are called axioms. I am sure many of us who have been used to let us say basic maths, where we talk about theorems which we prove and lemmas, and then we have what we call axioms. Axioms are taken as the standalone truths, and we use those axioms to prove many theorems. So, which means, for example, if I say that sun rises in the east for us, it is a given knowledge and it is a standalone, it is true in all contexts. Now, when we talk about operations on that knowledge base which contains sentences which are talking about some assertion about the world around it, we realize that agents need to interact with the knowledge base, which is typically in the form of actions called tell and ask. These are only placeholders depending upon the kind of strategy that one may adopt. They could be interpreted or they could be used with different let us say format or form, but this is essentially in some kind of you would say an intuitive way or a human way of looking at it. You say that if you want to give somebody a knowledge, you tell it, and if you want some knowledge, you ask for it. So, this is how these two keywords have been coined to say that a knowledge base will essentially operate with these two actions, that it will get updated when it is told some knowledge, and it will provide the required information when it is asked for it. So, this is how this whole process can be coded in terms of a kind of a structured format. So, when an agent asks the knowledge base gives an answer based on what it has been told through tell number 1, including inferences that are derived from other stored sentences. So, there are large number of stored sentences, and through reasoning process you could draw some inferences, and those inferences could also be stored as sentences. So, when there is some let us say action which is equivalent to asking knowledge base, and if that inference has been derived in such a manner that it pertains to the information that is asked for, it will be provided. So, it is here enough to note that inference is a definite process, and that follows through reasoning, logical or otherwise, from the given sentences, and of course, will be discussed in more detail in later sessions. But at this point, it is sufficient to know that inference is an important element of this whole process of agents which are going to work only through the knowledge base, that they will have to tell the knowledge base some new knowledge which has been generated through percepts, and then if they have to take an action for a given percept, it will ask the knowledge base to please provide that information. So, let us look at a sample program for a knowledge based agent, how would it look, and we will also try and see whether it follows the basic format of the programs for other kind of agents that we have seen so far. So, let us say function, we say KB short for knowledge based agent, it gets an percept. There are only two variables now, the knowledge base, the database and the time, because now the time becomes important. At what time the information was generated, because it is possible that there was an information which was generated at some earlier time and now that information is no longer valid and that a new knowledge has been generated at a later time. So, you say at a given time you tell the knowledge base or the database the sentence, make percept sentence, which means from the percept now you create a sentence which is going to go and reside in the knowledge base at with these two arguments, percept and time, that at this time for this percept this is the statement which has been stored in the knowledge base. Now, once that is done, the next step would be the action. The action will depend upon you ask the knowledge base and you make a query. So, now you have a query which goes to the database and the database looks for a sentence and that sentence corresponds to the action and that action is generated. And now you say that go back to the knowledge base and say that this action has been taken. So, you take a make action sentence and you increment time by 1 unit, whatever unit may be, and then you kind of keep going through this in a continuous loop, so that you keep generating, you get a percept, from the percept you create a sentence, tell that to database and then you generate a query, what action should be for this percept sentence. The database, based on whatever information it has, it will generate that action. So, you make another action sentence and tell it back to the database. So, you can see that given a percept, agent adds percept to its knowledge base, asks the knowledge base for the best action and tells the knowledge base that it has in fact taken that action for that percept. Now, that becomes a connection between the database, that for this percept this is the action which has been taken. Now, you might get an impression that this knowledge based agent design is similar to the agent which is model based, but there is an important difference between the two forms. Knowledge based program is not driven by a hypothesis. Now, if you look at the model based, model is nothing but a hypothesis about what is likely happening in the environment based on the actions taken by the agent. It is hypothesis and will have its own uncertainties. Knowledge base on the other hand is not driven by any hypothesis, but it is based on whatever it has been told, which becomes the stored knowledge. So, it will just take an action based on the stored knowledge, and now you can see where that omniscience comes in, that as your knowledge base grows, the stored knowledge becomes larger and larger and it kind of has information about all kinds of percepts and information about what action should be taken for those percepts. It will slowly approach an omniscient agent. For example, just to give you a simple thought, if a car which is let us say driverless, autonomous, going from Nariman Point to Panvel knows that Atal Setu is the best path, then its action is based on knowledge and not any calculation based on the model and the state, which means now it is not going to do any calculations. It will just say that okay, take me to Atal Setu, that is all. That is the action it is going to take, because it knows. And now you realize the power of a knowledge based agent. And such agents are created in an extremely simple manner by simply telling it the requisite knowledge. Now, from where that knowledge arises, you have to make an effort. So, that is where the effort lies, and whether that knowledge is correct, not correct, half truths. Sometime if you have faulty knowledge, suppose you know, or you think you know that if you take a left turn here, you will reach the destination. You take a left turn and you do not reach the destination, which means your knowledge was faulty. So, those are the kind of things that one needs to avoid, but ultimately it is an extremely simple agent design, so that you just simply tell all the knowledge, it goes to database, and then as it operates, it just takes the percept, it sends this information to the knowledge base says that for this percept, this is the action, you take the action, and that is all there is to it. Now, how does one do this? So, there are two different kind of schools of thought in creating these kind of agents. One approach typically is called declarative, in which the designer tells the agent each sentence one by one till it acquires all the knowledge needed to operate in its environment. So, which means now it is the designer's job to generate all the knowledge from whatever exploration, whatever the other sources, whatever the other areas, other learning mechanism, it generates, the designer generates all the knowledge, creates those sentences, and one by one it stores all the sentences in the database or the knowledge base by telling it till all the knowledge that is necessary to operate in its environment is input, and that is where the agent is complete. The other method is called the procedural, in which the desired behavior is directly coded as a program, and then the agent discovers for itself that if this behavior is to be achieved, what is the corresponding knowledge which will ensure this behavior. So, you write a procedure, and then the procedure generates that particular knowledge. In fact, both of these are good in their own rights, but generally in practice we employ a combination of both these strategies, that there are some things which are directly told and some things which are generated through a procedure. Now, knowledge based agents can also be a learning agent, in which it can be programmed to learn from itself through percepts. So, now you see the power that it brings, that if you can create an agent which is based on knowledge base, and that knowledge base now is getting updated through learning process, which is driven by the percepts. So, you can see that we are combining the power of the knowledge base with the power that is of self adaptation brought in by the learning agent. In this case, the knowledge from a series of percepts creates a liquid knowledge base that is used for actions, and ultimately it is found that all learning agents are fully autonomous, and this is the ultimate objective that most of us are achieving or trying to achieve, that we are trying to create learning agents which will operate or function in an autonomous manner. Now that we have established the role of sentence in the knowledge base, we introduce the fact that it has a technical nature based on the syntax of the representational language. So, we bring in the idea of a syntax. Syntax is generally defined as the format which ensures that the sentences are well formed. In fact, from our understanding of the natural languages, the languages that we learn from school and at higher levels, we learn syntax first. For example, how to write a sentence in English, how to write sentence in any other language like Hindi or Marathi or any other language, there is a syntax in terms of where to put the alphabets, where to put the various connectives, the adjectives, adverbs, all those grammars put together give you a format of a statement or a sentence, so that it is a well formed sentence. I will give you an idea. Suppose I write x plus y equal to 4. It is a well formed sentence in algebra. Algebra also has its own language, and this is a sentence in the algebra that it says that there are two variables x and y. When they are added, the result is 4. On the other hand, if I write the same thing as x 4 y plus equal to, I have used the same 4 or same 5 symbols, but it does not make any sense to me in algebra. It is garbage. So, it is obviously not a well formed one. So, this is the first step that we need to ensure when we are talking about forming a sentence which is as per the syntax of that representational language. That is what is meant by based on the syntax of representational language. Then sentences and logic. Thus, we see that there is a well defined structure and logic of the specific domain in the manner in which the sentences are required to be formed. It is very particular or specific to the domain. Further, we find that similar to any other language, we also need to understand the semantics, which establishes the truth of each sentence about each possible word, which means what is the meaning of that sentence, what does it mean, that is the semantics. For example, we know that x plus y equal to 4 is true in the context of x equal to 2, y equal to 2, or x equal to 1, y equal to 3, and so on. We could create all these combinations for which if I do this operation, the sentence will be true, but it is false for x equal to 4, y equal to 3, and all such contexts that result in number which is other than 4. So, this is what we mean by semantics. So, to conclude this session, knowledge is a feature that helps an agent to correctly interpret a percept, translate it into correct actions, and is expressed in the form of sentences about the world. Sentences are based on a representational language and similar to any other language are formed using syntax for their correctness and the semantics for their truth or falsehood. So, with that we conclude today's session. We will proceed with this particular idea of sentences and then how to check their truth or falsehood in a context of the sentences that we are going to create using different tools. We will look at in the subsequent sessions. So, bye for now and see you in the next session.